So hello and welcome everyone to our first Keptn online user group meeting of 2024. We hope you all had a wonderful holiday season and that your new year is going great so far. Today I'm joined by my colleague Florian Bacher, who is a senior software engineer at Dynatrace and also a Keptn maintainer. So Florian's going to be going over Keptn, the benefits, architecture, core concepts, and terminology, and then give a demo on how you can integrate Keptn into your Kubernetes cluster. But before I pass things over to Florian. Florian, would you mind advancing to the next slide, please? I'd just like to cover a few housekeeping items quickly. So we've bookmarked an hour for today's session. We may not go that long, so if you have questions, a lot of questions at the end, we have plenty of time for that. So don't worry about getting your question answered. We are using Zoom. We are going to be recording this session. It is already recording, and we can email you the follow-up link, or you can check it out on our CNCF Keptn community chapter page. We'll post the link there as well. So again, we'll take questions via the Zoom chat function in the Zoom program. So feel free to pop your questions in there at any time, and then I'll let Florian go ahead and go through his whole presentation, and then we'll wait and we'll do questions kind of at the end once everything is done. So feel free to pop those in at any time, and then I'll collect them and pose those to him once we're done. The only weird thing about Zoom, though, is when you do ask a question, unless you want it to be super private to just me and Flo, make sure that you change the to everyone so that all audience members can actually see your question in the Zoom chat there. Otherwise, there's a few ways that you can get in touch with us through the website, Twitter, GitHub. We are always open to contributions. So please join us in all of these places. And otherwise, I think that's kind of my quick spiel about housekeeping items. And I will hand it over to you, Flo, to kick things off officially.
All right, thank you for the introduction. Today I have the honor of giving you a quick overview of Keptn and what the goals are here in this project, how everything works together and what you can do with it. And we're of course also gonna have a look at a nice little live demo that consolidates all of the concepts that we're gonna get to know just about now. And yeah, hopefully you will find some answers in there, and looking forward to your questions after this presentation as well. So before we head into this, let's, as a first step, start with a little introduction about what we find is really cool about everyone's favorite topic, GitOps. So basically, in our opinion, this is just a natural way to deliver apps in Kubernetes, right? Because it comes with a number of benefits. So of course, having everything in a declarative way and versioned way in your GitOps repository is makes it much easier for DevOps engineers to kind of have this single source of truth for your application's configuration. And of course, due to the fact that everything is in the GitOps repository, it allows you to keep track of all the changes that might have been made to your application's configuration and adapt if anything broke during a recent change by going through the commit history and checking what was changed. And yeah, also due to the automatic reconciliation done by various GitOps tools like Flux or Argo CD, it makes it really convenient to always have the latest desired state of your application configuration within your Kubernetes cluster. So those are the things that we think are the great benefits, but of course there are there still might be some additional challenges when doing GitOps and deploying your applications with this approach, right? So first of all, you may want to know when your cluster is actually in a healthy state and when it's ready to upgrade your application, right? So you wouldn't necessarily want to deploy your application if, for example, you don't have enough resources available, or there is some other problem in your cluster. So before doing the automatic reconciliation and deploying a new version of your app, it still might be beneficial to check any prerequisites that you might want to make sure that are met. Then, of course, especially with microservice-based architectures, with a lot of different components within an application, it might be easy to lose track of how the deployment of your whole application is going, right? So if there are multiple services deploying independently from each other, but also some services might depend on other ones. So there it might be easy to get lost and lose the overview of how everything is going, and to figure out the exact place where anything might have gone wrong during the deployment of your application. And then finally, after the reconciliation that's done by the GitOps tool and applying your desired configuration, you might want to do additional checks whether your application is actually up and running. So not only that the current desired configuration has been applied, but that everything in your application is actually working correctly. And yeah, to solve these couple of challenges, we have been working very busily on the Keptn project. And with that, we aim to assist you with tackling these challenges. We've done this based on a couple of principles that we would like to adhere to. So first of all, we want to enable you to make use of Keptn with minimal configuration effort and with minimal changes to any Helm charts, for example, or any application manifests that you might already have. Then, of course, we want to integrate nicely with GitOps tools, and don't want to introduce yet another pipeline tool. So that's why we configure everything in Keptn with Kubernetes manifests. Then, of course, we would like to make it as easy as possible to integrate with any existing tools or solutions that you might have. And we want to give you a deep insight into your deployment process by providing as much observability data and traces as possible. Of course, with the goal of them being meaningful, so that we don't want to spam you with open telemetry traces. And yeah, we want to do this in a cloud native way, as I said before, so everything in Keptn is configured via Kubernetes manifests. And yeah, let's, in the next step, let's quickly go through the, I would say, big pillars of the Keptn project. So the first one is observability. So what we aim to do here is we want to give you a number of useful metrics for your deployment process. So we rely on or we provide DORA metrics, which we visualize in a Grafana dashboard that you can import into your Grafana instance. So there we have a custom dashboard that we have hosted in our Keptn repository, and that you can import into your Grafana instance. And with that, you get data like time between your deployments, how long a deployment of an application takes, how many of them are successful, how many are failed. And this should give you a good overview of your deployment process. Then we are supporting OpenTelemetry traces. So that means that whenever a new application deployment is done, you will get a trace representing the different steps that are part of this application deployment. So for example, the pre-deployment checks, then you get traces for the deployment of the individual workloads. So for example, deployments within that application. And also in case there might be something going wrong, as you can see in this screenshot here, you get this little red exclamation mark where you can quickly figure out in which phase a problem might have occurred in case there's anything wrong with your application. And the cool thing about that is that you get these benefits, so the observability part, pretty much out of the box, as long as you, of course, have Keptn installed and enabled for the namespace your application is running in, and as long as you're making use of the Kubernetes recommended labels for your application. So that's the Kubernetes IO/name/version and instance labels. And if you have them set up on your application, then you will pretty much immediately get this observability data. All right, then let's jump to the next step, or the next big pillar of Keptn, which is pre and post deployment tasks and evaluations. So as I said before, if you have your GitOps toolset up and running and everything is applied automatically in your cluster, you might still want to check if certain prerequisites are met. And with this concept, you can define pre-deployment checks for either your whole application or for individual workloads, where you can check for error budgets, infrastructure readiness, or where you can run certain tasks to prepare your infrastructure. And you can do this in a number of various ways. So the first way of doing that was to enable you to write simple JavaScript code with our Dino runtime, where you could execute custom logic. Since a couple of months, we also provide the possibility of executing Python scripts and also any arbitrary container that will then run as a job for this pre-deployment task. The same also works for the individual workloads. So if there's anything specific that needs to be checked there, you can also define tasks for those. And of course, after everything's deployed, you can also do the same so you can define tasks or also evaluations for post-deployment, where you can, for example, run load test tasks against your newly deployed application, and then also do some evaluations where you check for certain metrics to reach a certain target value. So for example, in this very simple example, we check whether the result of some Prometheus query exceeds or is below a certain threshold. And based on that, we mark the post-deployment phase as successful or not. Then, since recently we also support more flexible and more powerful ways to analyze your application performance using the analysis definitions. So if you have worked with Keptn v1 in the past and have made use of the SLO quality gates, then this would be pretty much the equivalent for the new Keptn. So in this analysis definition, you can define a number of objectives that you would like to meet. There you can, for example, check whether the response time P95 percentile is below a certain value, and if it's above that, then the evaluation is failed. And here you can refer to so-called analysis value templates, and these pretty much describe from which monitoring provider the data should be fetched from and which query should be run against this particular monitoring provider. And then whenever you execute such an analysis, you do that by applying a Kubernetes manifest for an analysis resource. And within the status of this resource, you will then find the result of the analysis. So also here, just a little sippy poo. Also here, you can make use of Kubernetes manifests all the way in order to stay in line with the cloud native approach. And yeah, just really quick before we head into the demo, how do you actually configure your application? So as I said, if you just want to make use of the observability features of Keptn, you just need to provide a certain number of labels or annotations. So that's done by either our Keptn specific annotations like Keptn sh/workload and version, or Keptn sh/app. And those are the equivalents to the Kubernetes recommended labels, like instance, part of, and version. I won't go into too much detail here because this can be read in the documentation where it's explained in more detail on how you can configure your app. But pretty much adding these annotations or labels will suffice to get the observability data. And then by adding further annotations like the pre-evaluation and post tasks annotations, you can then define the pre and post deployment checks that should be, or evaluations that should be executed. Yeah, and I would say that's enough for theory. Let's jump into the demo. I hope you can still see my screen because I don't see the Zoom screen sharing indication.
Yeah, it looks good.
Okay.
You might want to increase, if you can, a little bit, Flo. Just increase the size just to make sure.
Of course, yeah.
Awesome, thank you.
All right. Yeah, we're now in my Visual Studio Code. This basically contains the content of my GitOps repository. So here I have a Helm chart for a very, very simple app called Simple Go. This consists of 2 deployments and 2 services. And they don't do particularly much other than being deployed with Keptn, but I think they get the demo across. And yeah, as I mentioned here, I have the Kubernetes recommended labels in this case set. So the name of this particular deployment or workload is Simple Go service, which is part of the Simple Go application. So the application consists of those 2 services that we have defined here as deployments, and the version number I set via a Helm value that I can define here in this value file. So here I have the service version, backend service version, and also the commit ID. To that I will come later. And yeah, the deployments themselves are pretty unspectacular. But the next interesting part here is the Keptn app context. So this allows you to, first of all, in the next version of Keptn, propagate some metadata. So for example, this commit ID here, this will be attached to the OpenTelemetry span that we're going to create, and that will allow you to correlate the application deployment to the particular commit ID in your GitOps repository. And then For the pre-deployment tasks, in this case, I thought it might be a nice example to make sure that our monitoring solution, which is Prometheus, is up and running and ready to gather monitoring data. And then after the complete application has been deployed, I would like to run some load tests against the newly deployed services. Then the Keptn task definitions here, those will execute those tasks. In this case, I'm making use of the recently introduced container runtime, where I just point to a particular container image, and then that will be executed as part of this of the pre-deployment or post-deployment check. And when that has been executed successfully, the whole deployment will proceed further. Then, yeah, similar thing for executing the load tests. And also, yeah, and then the task definition for waiting for the Prometheus instance to be running. And then, yeah, as a post-deployment step for the individual workloads, before I actually start with the load tests, I would like to make sure that those two services are monitored by Prometheus. So here I wait for the Prometheus target for both of the services to be ready, and for the indication that data is being collected for those services. And that then tells me that I can proceed with the load tests, because otherwise it wouldn't make much sense to execute them without actually gathering any monitoring data that I can evaluate. And yeah, for analyzing those load tests, I have prepared a little analysis definition where I have basically two targets. So first of all, I would like my response time P95 percentile to be below a certain threshold. So I don't want to exceed it 500 milliseconds, otherwise it will fail. And if it's below this 500 milliseconds range, but above 300, I would still like to mark this objective as a warning. And then, of course, I would like the error rate to be 0, otherwise this objective will not be reached. And what we provide here is the possibility to assign certain weights to each of the objectives. In this case, they're both weighted equally, but for example, if you deem your error rate to be a much higher priority, you can increase the weight here to, for example, 10 or any value, and then the result of this objective will contribute more heavily towards the calculation of the total score. And with this total score, you define a passing score that you would like to reach in order for the complete analysis to be successful. And then finally, real quick, I have the analysis value templates for those objectives. So I have the query for the response time percentile and for the error rate. So those are two very basic Prometheus queries. Won't go into too much detail here. And then I finally have a Keptn metric where I also execute a certain query for the response time. And now you might wonder, why do I have an analysis value template and a Keptn metric? Don't they do the same thing? It's similar, but a big difference here is that the analysis value templates represents the value for a concrete time frame, right? So for example, the time frame during which the load tests have been executed, whereas the Keptn metric always represents the latest known value of that metric. So this is basically for continuous monitoring of that metric. And we've done this to support solutions like horizontal pod autoscalers. That, if I scroll down, yeah, here it is. So here we can observe the value of this metric, define goals for that, and based on that, we can automatically scale our workload up or down between the range here that we have defined here. So for example, if we notice we're above 0.4 seconds for the response time, we allow the horizontal pod autoscaler to increase the number of replicas. Yeah, those are the relevant manifests. I know this is quite a lot, but yeah, to show you how this can work with Argo, let's jump into the Argo UI. Don't worry about this sync failed. This is because in order to restart the demo, I've deleted the namespace. Now it's in a sync failed state because the namespace is enabled, but to is deleted. But to kick everything off again, we start the synchronization again, and now everything gets reconciled. And to see how things are going, let's jump into K9S. Actually, let me make that a little bit bigger. And what we're going to see here is the pods that are deployed in this namespace. And as you can see here, the SimpleGo backend and SimpleGo service are not yet running. They're in a pending state. That's because Keptn has hooked into the deployment of those and waits for the pre-check. So here we have the pre-wait for Prometheus to be done. And only when that precondition is met, eventually the pods will be allowed to be scheduled by Keptn. So there we are making use of the recently introduced scheduling gates that have been added since Kubernetes, I believe, version 1.26. And now we can see the first pod being up and running. So this is the SimpleGo backend. The second one should be joining the fun as well. Yeah, now we're in the container creating state, and also the post wait for monitoring step has kicked in. So now we're waiting for the monitoring data for the deployed services to be ready. And once this step has been done, we should see another pod spinning up, which will execute the load tests for both of the services. Just if we give it some time, now this is done. And in a couple of seconds, if the demo gods are merciful today, we should see the load testing pod. The suspense is real. And now here we have it, 2 even, because we're testing both of the services. So now those are running. Those will be running for a very short time, just to keep the demo within a limited time frame. And once those are done, I believe the complete Keptn application deployment should be ready. Of course, you don't need to only watch the pods, but for example, you can have a look at the status of the Keptn version CRD to get an overview of the current deployment. And here in the status, it will tell you in which phase it currently is. So right now we're in the post-deployment task phase where we're executing the load tests. And then you can also see the result of the individual subphases and whether those are succeeded or not. And it seems like it's still running. Now it's in a succeeded state, and now our application has been deployed successfully. And of course, you don't need to just keep track of your application deployment via K9S or kubectl, but you can also make use of our Grafana dashboard. I might have to restart the port forwarding real quick. Let me restart that, and there it is. So now we're on the Keptn dashboard where we show our DORA metrics. So we have 4 succeeded deployments. Currently, there is no active deployment because everything has been completed at this point in time. And yeah, we don't have the average time between deployments yet because I'm inspecting only the last couple of minutes. Okay, so here the demo got out playing a little trick on me, but this is live. Yeah, usually you will see the average time between deployments here. Maybe it was because I restarted something in preparation for the demo. But anyway, let's jump to the next interesting part, which is the deployment trace. So this looks a little bit like a Super Mario level, but this is the deployment trace for the complete application called Simple Go. So this is the root span. And as children of this span, you will see the spans for the individual subphases, like the duration we waited for Prometheus to be ready, then the app deployment phase of the individual deployments. And here you can see nicely the post-deployment load tests have only been started once we were making sure that our monitoring data is available. And then if we have a look at the attributes, this I promised you earlier, we injected the Git commit ID into our Helm chart in order to be able to keep track of the commit ID that basically triggered this application deployment. So this is the observability part. We have seen how we can do pre and post deployment checks. And then finally, since we have executed some load tests, let me show you an example of an analysis. So here I have a very simple analysis in CRD that will basically trigger an analysis for the recent 10 minutes. So this is hopefully the time frame in which the load tests have been executed, unless I've been talking too much or too long. So let's use this little make command. So this will do nothing more than apply this resource, and then the metrics operator will kick in and try to reconcile this resource by executing this analysis. And then we are retrieving the status of this analysis, and there we are using JQ to kind of format this detailed breakdown of the analysis result. And there you will see the result of each objective, what were the conditions for that, whether it was fulfilled, whether it was a warning result or a pass, and which value we actually got for this query, which query was executed, and finally the total score and whether we passed or achieved a warning result. And of course, if we have failed it, then we will see that as well. And yeah, I know that was a lot to take in, but just a really quick overview of Keptn and its concepts. And I hope I could give you some interesting insights. So now I'm gonna hand it back to you, Stacy.
No problem. Thanks, Florian, for that great demo and the slides before. So I had a couple questions sent to me privately, and I'm just going to ask them instead of putting them into chat. But one of them is, you mentioned providers. Can you talk a little bit more about providers in like what kind? Is it just Prometheus? Can you just kind of dive into that a little bit?
Yes, of course. So basically, Keptn metric providers are another custom resource which tell where to fetch monitoring data from. So essentially those include, the specification for those include the provider type. So here we have a number of supported providers, which is the Dynatrace Metrics API, Dynatrace DQL, Prometheus, and Datadog. So those are the ones we currently support. And then, since of course you need to tell the operator where to fetch the data from, they include also a target URL, which points to the API URL of your monitoring provider, and then a reference to a Kubernetes secret, where you need to store your access token for accessing the API of that provider.
Cool. And maybe we can pop a link into the chat that describes that a little bit more. I'll look for that in just a second. And I would just like to remind everyone in the audience, like if you have any questions, now's the time to put them in because we'll be wrapping up soon. A couple of other things. One is did you want to finish this recap slide real quick? Or do you want to hold off and just
I will put it here and
take questions?
think
okay.
I went through these points. But
yeah. And actually, you can just probably go on to the next slide as well, just to remind people of like where they can go in case they want to, connect with us and stuff like that. So another question that I have here is, I want to test out a simple task, but I don't want to waste time every time building a container. Is there an option for easy task deployment, or sorry, easy task development or tryout?
Yeah, it really depends in which language you would like to do that. So for example, if you would like to code your task in JavaScript, for example, you can make use of the inline code definition within the task definition. So there we have a property that allows you to directly put the code into the Keptn task definition resource. That would be one way of doing this. So that's supported for our Dino runtime and for Python. In case you would like to use anything else, like a Bash script or Go, like I did for my example, it really depends on the tools that you want to use here. So, for example, if you're doing Go, you can develop your task within your IDE, test it there, and once you have some confidence that the code is ready, you can build the image and then execute the task there. Or you can also directly execute it as a Kubernetes pod using the kubectl run command after you have built your container.
Cool. So a couple more sort of Keptn metric focused questions. One is it possible to use Keptn metrics with KEDA, KEDA?
With KEDA, that should be supported. We are looking into writing a guide for exactly that in the near future. So more details should follow soon.
Right. And then can I use multiple metric providers for a single analysis?
Yes, that's my favorite question, because that was a big feature that was often requested in Keptn v1, but now in new Keptn, we do support that. So you can, in your analysis definition, can, for example, reference one analysis value template that fetches the data from Dynatrace and another one that fetches the data from Prometheus. So that's definitely possible now.
Great. Well, I think that's all the questions that came in to me directly. If anyone else in the audience has any, I would say please type them into the chat now and we'll get Flo to answer them. Otherwise, please connect with us. Give us a star on GitHub at Keptn Lifecycle Toolkit is the main repository there. If You can join us on Slack. That is a great way to get in touch with all of the maintainers. So we're just on the CNCF Slack, which is cloud-native.slack.com. And our channel is Keptn, of course. And if you need an invitation link, you can just search for Cloud Native Slack inviter or join Cloud Native Slack, and you can find a way to invite yourself if you're not already there. And then I think we've included a basic sort of getting started guide. Florian, is this getting started lifecycle management? Is that kind of what you walked through today? That's a good guide for people to navigate towards?
Yeah, pretty much. So that was that would be basically the starting point for doing something similar like I did in this demo. So this explains, how to annotate your deployments, how to configure pre and post deployment checks for them and for your whole application. And this will be a good starting point, I think, to build up from. And then also from there, you can look into metrics, auto scaling, and doing analysis.
And then for future events, we're going to be trying to host these Keptn online user group sessions monthly going forward. So make sure that you go to community.cncf.io/Keptn-community. That's where all of these sessions will be listed. You can register there. And yeah, we look forward to seeing you in the future. So thanks everybody for attending today. Connect with us offline if you want. If you have any additional questions, come and join us on Slack and GitHub. And otherwise, we will see you next month. Thanks so much, Flo, for this great presentation and demo today.
Thank you.
All right. Take care, everybody. Bye-bye.
Bye.